Meet Robert. Robert is a highly intelligent robot whose mission is to collect and return rock samples on the planet Venus. Of course, Robert cannot do this alone. That is why Robert has a companion that is an exact female replica of Robert himself called Patrice. Both robots are equipped with tools to help them find rock samples. First of all, both robots are equipped with two IR sensors pointing down in front of the wheels on either side of the robot. These sensors will sense the amount of IR light received after transmitting. Based on that information, the robot can judge whether the reflecting object underneath the robot is ground or a cliff or crater. The detection of the cliffs and craters will be used to prevent the robot from falling in craters or off the edge of a surface. The robots are also equipped with an IR sensor attached to a trunk-like mechanism on the front of the robot. This sensor will work in the same way as the previously mentioned ones, only with the purpose to verify whether an object in front of the robot is a rock, which is highly reflective, or a mountain, which is significantly less reflective. If the robot senses a high reflective object, it will use the position of the head to find the angle to turn and pick it up. Next to those attachments, the robots are equipped with an ultrasound sensor on top of the robot. This sensor can turn 180 degrees from left to right and sends out an ultrasound wave. This ultrasound bounces off objects and will then be received by the robot, which can be used to detect objects and their distance from the robot. This feature will be used to detect and get the distance to rocks and mountains, which can then be examined with the IR sensors. A second use for the ultrasound sensor is to find the entrance to the lab using the flaps on the lab. If the robot is near the lab and senses it in front, it will drive towards it until it almost bumps into the lab. It will then sense 3 points: front, left and right. If the robot sees the flap on the left and the lab in front, it knows to turn right. The same will happen if the flap is sensed on the right. To communicate with each other, both robots use Zigbee modules. These modules can send and receive data on a channel. Both modules have to be set to the same channel to work correctly. Since the robot is highly intelligent, there will be no problem if the robots send data at the same time. The Zigbees will be used when a robot detects an object, to avoid robots detecting each other. Whenever a robot detects an object, it will ask the other robot to move a certain distance. The robot will then see if it still detects the object under the same condition. If it does, the sensed object was not the other robot. If the object is not sensed anymore, it means that the sensed object was the other robot. Another important use is to tell the other robot to wait when the robot enters the lab to avoid getting two robots stuck in the lab. To avoid the robot from tipping forwards, the robot is given a counterweight on the back. The counterweight consists of a delicately engineered sheet of metal that is bent to an ellipse shape filled with rocks. Complex calculations were used to provide the robots of the right amount of rocks. Finally, to return to the lab, both robots have all-spectrum light receivers on the back. In combination with an IR transmitter on the lab, the robots will be able to sense the lab and follow the general direction of the robot to then sense the lab with the ultrasound sensor. Now that the robots are properly equipped, we are ready to launch.
Start, 2, 1. Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.